Hello again, everyone, and thank you for attending today's webinar, Streamlining Product Development, Designing from Scan Data with Geomagic and FARO. This is brought to you by WTWH Media. We would like to thank our presenters today, Les Baker from FARO and Gregory George from Geomagic for being here. I'm Leslie Langnaw, Managing Editor at Design World Magazine, and I'm your moderator for today. Just a couple of housekeeping details before we get started. If you wish to tweet about this webinar anytime during or after, please use the hashtag DWWebinar. And if you have questions, we will be addressing those questions at the end of the presentation. But you should see a box where you can enter them at any time during the presentation, so feel free to do so. Also, this webinar will be made available to everyone who registered at designworldonline.com, and we will be sending it out via email shortly after the presentation. So first, I'd like to introduce to you our speakers. Les Baker is an applications engineer from FARO Technologies and has over 24 years of experience in engineering and design, including 15 years of experience scanning for reverse engineering and design. Before he joined FARO, Les worked in various engineering capacities within the electrical, plastics, automotive, and aerospace industries. Gregory George is an applications engineer with Geomagic. He has over 10 years experience in CAD modeling, CNC programming, 3D digitation, and manufacturing industries. Gregory holds an AS degree in graphic design technology, and as I mentioned before, our speakers will be available after their presentations to address any of your questions. So without further ado, we are going to begin this presentation with Les.
Thank you, Leslie. Hello, everybody. The agenda begins with a slide presentation by me describing FARO, the techniques and equipment that allow acquisition of as-built data on critical and key characteristics on people's parts. That will be followed by Greg with a slide presentation of Spark's abilities to model new parts from scratch, to digitally define as-built condition and incorporate modifications that have been captured by equipment such as the FARO laser ScanArm. And finally, Greg's going to give a live demonstration of the simplicity of Spark with some examples, and that will be followed by a wrap-up and a Q&A session. So, laser scanning with FARO. FARO has been provided digitization equipment to industry for over 30 years and is one of the world's most trusted sources of 3D measurement technology. We started initially with small single-point tactile units, but the range has expanded to include articulating arms, laser trackers, laser scanners, and our own range of software. The Edge and Gauge are our current arms, and with length from 4 foot to 12 foot and the ability to leapfrog, the user has access to high accuracy tactile and non-contact, feature-based and point cloud capabilities, and it's ideal for small to medium-sized objects. The Laser Tracker Vantage can capture high accuracy tactile data up to 262.5 feet from a single position. Also, with the ability to leapfrog, it's an ideal tool for very large-scale metrology projects. Our laser scanner focused 3D product works over a very large scale, up to 800 feet in range, and acquires massive point clouds with up to 1 million points a second. This allows very detailed photorealistic visualization with the ability to extract measurements from the underlying point cloud. It can be driven by our own software, by Cam2 and Scene. These are our own award-winning metrology and large-scale point cloud handling softwares. There are many types of technology solutions on offer for scanning, which include white and blue light imaging systems. These usually require an independent method to place all separately captured images within the same coherent data set. And this registration is typically done as a post-process, so there's often no real-time feedback for the operator. But there are also laser line probes, which require attachment to a localizer device. This allows each image to be displayed in its correct position and orientation in space as it is captured in real time. We'll focus on those types of probes that can be used in tandem with an articulated arm. The laser line probes with portable CMMs. So how does laser line scanning work? The process is very simple. A laser line probe is a non-contact scanner, and it's attached to a 7-axis FARO arm. The laser projects a line onto the object surface, and a camera captures the profile formed by the laser line 60 times per second and determines the location for each point along that stripe. Those points are then rendered into a point cloud. A scan with a laser line probe will produce a point cloud, which is just a large 3D group of points that correspond to the geometry measured. Those scans are typically acquired for two main reasons. The point clouds can be exported to CAD and developed into models for downstream use in activities such as simulation, analysis, or development. And they can also be used for inspection, which confirms the product's dimensions and can initiate actions such as troubleshooting or corrective action responses. The FARO Edge ScanArm is FARO's latest offering to meet the increasingly demanding requirements of people who need portable arm laser scanning capability. This is the world's first smart arm. It integrates seamlessly with Geomagic Spark. It has an innovative integrated touchscreen and operating system for true portability in the workplace. Wireless connectivity is available via Wi-Fi and Bluetooth, with wired connections also available via USB and Ethernet cable. It's very lightweight of only 2.7 ounces and low form factor allow obstruction and collision-free measurements to be taken with the contact probe or the laser line probe, and switching between the two is absolutely seamless. The fast data capture rate for point cloud is 45,000 points a second. In close-up, the LLP looks like a spare handle that you switch out as desired with the regular handle on your FARO Edge arm. The laser emitter is a known baseline distance from the camera and is also at a known angle, allowing for easy triangulation of the coordinates for the points captured. The calibration plate allows the operator to simply establish the orientation and position of the laser line probe relative to the FARO arm. Of the main applications for the FARO arm and the FARO ScanArm, we're going to concentrate mainly on the last one there, the reverse engineering, where Greg's going to talk us through how to create a model from digitized data from the FARO ScanArm. I've reached the end of my part of the presentation now, and I'll be handing the baton over to Greg, who's going to show you a reverse engineering application for scan data. These days, the applications for using scan data acquired by your FARO Edge ScanArm are limited only by your imagination and your software. The technical handover behind the scenes should only take a few moments, and then you'll see how Spark will reduce the amount of perspiration required to complete the well-known perspiration against inspiration equation we're all familiar with in product development. So Greg.
Thanks a lot, Les. Again, my name is Greg George from Geomagic. And if you guys could switch back over to that presentation, I have a few slides to show in that PowerPoint about Geomagic. And then I'll switch back over here and show my screen and demonstrate the software live.
Bear with us a minute while we get that taken care of. There we go.
So today I'll be showing Geomagic Spark. Before I show Spark, I just wanted to talk a brief moment about Geomagic as a company. We've been in the industry for over 15 years. And we have a saying around here, we make the real digital and the digital real. We are the third-party software that can connect to devices like the FARO Edge arm and capture that information and then process it in a variety of different ways. And we'll go into that a little more later on in this demonstration. We also have another software, Sensible, which you may have heard of, is designed in an organic fashion using a haptics device. If you get a chance to look up Sensible Technologies, that's another product that we own as well. And we have a variety of different customers in different industry segments, from education, government, research, even toy companies in the Sensible realm. We have a huge span of customers. So what is Geomagic Spark? It's a new scan-to-CAD modeling software, and we developed it in conjunction with SpaceClaim's API. So what you're seeing is a product on screen that is half Geomagic and half SpaceClaim. And if you're familiar with SpaceClaim, they're a direct modeling CAD package that's out in the market today. And one thing that many designers have been desiring over time is the ability to model over top of scan data in a CAD environment. And that's what Spark is designed to do. It's a specialized mechanical part design software package. It's a standalone solution. So there isn't the process of processing in one package and exporting and importing into another. You can do the entire workflow in one software package. So you can see that we can handle assemblies, we can tolerance the parts, we can create prints, and it's a perfect solution for mechanical engineers, designers, for typically prismatic shapes in manufacturing environments. One way to describe Geomagic Spark is you have these three circles here on screen. This graphic depicts it very well. For many years, these three circles had to be divided up into different software packages in order to come together to create one solution for the customer. In this case, you would need some sort of plug-in to connect to a scanning device and collect the information and scan. And then you would progress over to the bottom left where you would process that point cloud information. You would crop it. You would smooth the data. You can edit it in a variety of different ways. And then on the bottom right-hand side, then you would need to take it and model over top of it in order to create a CAD model. Well, Spark takes these three categories and puts them into one package, as I said before. So Spark is a powerful point and mesh editing tools, again, integrated with SpaceClaim modeling environment. And it's a natural home for fitting features to CAD. And it leverages SpaceClaim's direct modeling tools in the same environment, as you guys will see in a couple moments. here's a picture that depicts how the process is going to work when I switch over to Geomagic Spark. On the top left there, you'll see that I'll have a scan. And then you create a mesh of that scan. You're going to connect the measurements together into a mesh surface. And then you can segment it in a variety of different ways, which is basically an advanced selection tool. Then you can extract the geometry. So you would tell the software that this region is an extruded region or a revolved region, and then extract that solid geometry. And then on the left, you can see that you end with a finished model. So now I'd like to go ahead and switch over to Geomagic Spark. I'll show my software on screen. And I have a model of a guitar here that I'll go ahead and show, just like we have in the picture. And this is a live demonstration, so if there's a little bit of lag, I'll make sure to go slow enough so everyone can see the software. You can see that I have a scan data set on screen that Les sent me. He scanned it with the FARO Edge. And basically, I would like to show how that process works inside of Geomagic Spark. If you look at the screen, you'll see that it looks just like SpaceFrame, but we have a bunch of different tools that we've added in here. If I click over to this tab, this is the Acquisition tab, the Capture tab. And this is where you would connect directly to the FARO Edge and scan and hard probe directly inside of this environment. And that's where you can crop and edit that scan data. And then move over to the Design tab here, where then you can model over top of it. And some of the tools that I'm going to use today are over here on the right-hand side in the Extract dialog. So immediately after looking at this part, the first thing I would want to do is extract that outer profile, that organic shape that the guitar has. So I'm going to use a fit extrusion command. And I'm going to click on the triangles on the outside of the part, and you can see that there's a selection there. It turns red. And just like Windows or Microsoft products, I can hold Shift and select more missing faces. So you can see I can make sure that I have a complete selected area around the outside of the part. And it's very easy to click and select triangles in here because we have a smart selection tool which allows you to click and drag and gesture on screen up and down, and it'll select more and less triangles and fill that entire region and help you select very fast. You can see that it also has a preview of the sketch in the middle of that extruded area. Right now it's best fitted to the direction of the data that's there, but I can use this option right here, Constrain Orientation, and click on the Z-axis. And that'll make sure that when it does extrude this geometry, that it'll make sure it constrains that to the Z-axis. Over on the left-hand side, I have the ability to change some options. I'm going to tell it, upon completing this command, I would like a solid object on screen. I do have the ability to tell it to give me only the curves or a sketch. Then I can manipulate that in any way using the sketching tools, and then extrude it manually using the pull command. And then below that, I have curve options. I can tell the software, do I want it to fit a spline or a line arc sketch? In this case, I'm going to keep it as a line arc sketch and hit complete. And it happens quite quickly, but you see that it automatically created a solid extruded body on screen. So if I toggle off, you can see that I have my sketch underneath as a solid. If I turn it off, you can see that now I have just a solid object on screen. Now using the gesture-based direct modeling tools in here, for instance, the pull command, I can come into pull and double-click the top edge and select the whole region and pull and create a fillet on the top. And I can pull up to any dimension that I want. In this case, I'll use 5 millimeters. So you can see I easily just created a 5 millimeter fillet on the top. The same thing goes for the bottom, except this time I want it to have the same fillet dimension. So I can use the up to command and click on the top fillet, and it'll match the same. So if I rotate down to the bottom of the guitar, you can see now that I have the same fillet on the bottom as I do on the top. Now let's go ahead and hide that solid and turn on the mesh again. You can see that I would like to go ahead and fit the pockets that are inside that hold the pickups. I can go back to that extrude command. I can fit them all at once, actually, just by using that smart selection tool and dragging on screen. So you can see I selected the first pocket, and select the second pocket, and there's the third one. I can rotate around, just double check and make sure I have a complete selection. I can constrain it to the Z-axis as I did before, just to make sure that it's extruding in the right direction. And then I can hit the complete. And you see that it fits 3 separate solid bodies to that mesh. So if I hide the mesh again and show the main body, I can come directly into the combine command, select the main body, and then subtract away each individual pocket. So now you can see I have the 3 pockets cut inside of the body of the guitar. One really nice thing about this is you can see I have some different fillet radius on the on this pocket on screen. If I zoom in here, if I want to remove those fillets, I can grab the pull command and just drag it and remove that fillet. If I want to come back in and apply it again, I can drag it and enter in a dimension. So you can say 5. Maybe I want to use a 5 millimeter radius there. Also, you can tell in this other pocket, maybe I have a couple arcs coming in as a blend in the corner. I can use the fill command. I can select both of those faces and say to fill that, and remove those, and then maybe grab the pull command, select that edge. Let's do it as a 10 millimeter. So you can see it's very easy to select and modify the geometry. This is just a solid on top of a mesh, and you see that solid geometry is over there. There isn't any feature tree. I have a bunch of tools that are designed to interact directly with the solid itself. So I can make changes. I can move the pockets around. I can delete faces and manipulate them. So you can see you can interact directly with the solid itself. Let's go ahead and cut where the neck fits in. This is a good chance to show how I can select the mesh geometry here. You see the preview on screen. I selected just the pocket. I can go ahead and constrain that as I did before to the Z-axis. But this time I'm going to say only output a set of curves for me instead of giving me a solid. So I'm going to hit the complete box, and you see it jumps me right into a cross section of the mesh, and I'm in a sketch. So I can hit plan view, which takes me normal to the direction of the sketch, and I can remove that line that completes and makes it a closed sketch. I can remove those 2 little curves on the end, and I could draw in a line here to go ahead and trim the others too. So you can see if I rotate that in 3D, that I've created a bounded sketch for that pocket. And all I need to do is go back over to 3D mode. And a nice thing about the way Space Claim works is any bounded sketch automatically gets converted into a surface. So I can immediately come over and grab the pull tool and say I want to pull this up to, and click on the mesh itself, and it'll extrude that pocket up to the top of the mesh. So you can see that I've created a block where that neck is going to fit. Now if I turn the mesh off and turn the solid on, you see that I can come in here and see the two on top of each other. In this case, what I like to do is do a split face. And I can select this side face. And maybe I want to split the face right here. And I can use the pull command again to pull this in that direction just to make sure it trims all the way on that edge piece. If I zoom out to show the entire body, I can use the Combine tool again. Select the main body. Select the main body. Before I do that, let me just undo and pull this again. Now if I select the same main body and subtract the pocket away, now I have the spot for the neck. So from here, if I wanted to make a couple more edits to the solid, I could create some reference planes. And then maybe I want to edit the depth of those pockets. I could come in and create I can edit it in a cross-section mode. In this case, I'll go ahead and select this center line, go into a cross-section, turn the mesh back on. And if I zoom in, I can use the pull command in a cross-section and pull the depth of those pockets up to the right level. And all I need to do is switch back to the 3D mode again. I'll turn off my reference planes, and you can see that I have the completed guitar model. Now, as I mentioned before, because this is a complete package and I can do the complete workflow in here, I can come over to File, New, and create a drawing sheet with this guitar. So if I needed to create and output a drawing, you can see it immediately throws it into a default drawing sheet. And I can pull dimensions on this. For example, if I just grab the dimension tool and grab this line, and I didn't override any of the dimensions, so it's gonna be exactly what it is here. I can also pull out some general views here if I wanted an isometric view. And a neat thing about the fact that we've integrated these in together is that isometric view, maybe I don't want that to be the solid geometry. I can turn on the scan data. I can throw the scan data inside of the drawing itself, so you're looking at the actual part that we scanned. Another thing that's really neat about how the drawings work here in Spark is if I rotate the drawing, you see the drawing is actually in 3D as well. So the 3 instances of the solid are inside of the drawing, and 1 instance of the scan data are inside of the drawing as well. And I have the ability in here to manipulate the part while I'm inside of the drawing. So if I grab the Move tool and click on the space and drag it in this direction, maybe I need to make a change to that. If I zoom out, you see that in all the views, I've moved that pocket in the same direction and everything updates. And that, of course, is in the drawing. And it not only updates that part, but if I click back over to the part itself, you see that on screen in the modeling environment that it updated that pocket as well. So that's a short demonstration of Geomagic Spark. It shows a lot of tools, the ability to fit and extract geometry. Now I'd like to switch back over to my PowerPoint and just show a couple more examples of different types of parts that were done inside of Geomagic Spark. So on screen, very quickly, I'll just show a few examples. These are the types of designs that you can do. And you see the pull-out here that you have the scan data and a cross-section over top of the solid geometry. The second example coming up here is an example of a more organic part that you can fit freeform surface geometry as well to the scan data on screen. So this is a great example of how I can fit freeform geometry and model directly over top of it and use that as a template for my design or redesign. Here's another example of scanning a cell phone case. This software can also be used not only to reverse engineer the existing part, but also design a mating part. So you could actually design a case for the cell phone as well, directly over top of the scan of the cell phone itself. And then here's an example of how you can use scan data, remodel it, and third-party plugins that run on top of SpaceClaim's environment. So Spark, not only can I model over top of scan data, but there are third-party plugins that work with it as well. And this one, in this case, is an example of taking the model that we designed and throw it into a rendered screenshot of this guitar pedal here. So that concludes my portion of this presentation. I think we're going to transition into a question and answer time now.
Yes, we are. So if anyone has would like to put down any of your questions, you can do so now. We're going to start with a few people have already entered some questions. So one of the questions that we're going to go into is, could you perhaps show the remeshing abilities, Greg?
Yeah, actually, if you wanted to click over to my screen, I can show that there are some remeshing abilities inside of the software. Mm-hmm. So if I click back over to the part, turn on the mesh.
There we go.
And I go over to the capture ribbon. Inside of here, just a quick highlight just to make this fast, but after you connect and scan using the acquire section, you can edit by selecting. You can align the scans together, as many of you know, when you scan an object, many times you have to scan it in more than one position to capture all the geometry. Then this third section, we have the ability to process the point cloud, so you can reduce noise, sample the data, reduce it down to a lower level of information, and then what we call wrapping it, which is converting it into a polygon mesh. And then you have the ability in this mesh section, we have a repair tool that looks for inconsistencies in the mesh and fixes those automatically. And then we have a simplify tool that will also drop the level of the triangles or the fidelity down. And then we have some interesting tools here as well to fit a symmetry plane as well and things like that. So those are some of the ones that we have inside of Spark, just to give you an idea of what's there.
Okay, why don't you stay on there because we're getting some more questions involving your demo. So the next question that's coming up is, can you show an example of the freeform surface tool in the software?
Yes, I can. This part doesn't have a great example of it, but what I can do is just create a quick selection and show you here what it'll look like. So if I just create a manual selection on this area, you can see this is a organic shape here on screen. I'll hold Shift and make sure I select enough geometry. This will be a basic example. If I come over to Freeform and I tell it to fit, it'll look at that geometry and fit a freeform square patch to the geometry that's there. It'll take it a second before it shows up on screen. If I turn off the mesh, you can see what it fit to the screen. And again, this I know is not the exact application that you'd use this freeform tool for, but it's nice to be able to fit to freeform geometry. And then inside of this software, you do have the ability to use the tweak face command as well. So if I click on it, I can use my direct modeling tools to then tweak the face that I fit to the original geometry. So that is a really powerful tool. That is a good question.
Okay. Another one that's come in is there a way to see how accurately the extrude fits to the scan data, perhaps a color deviation plot?
Yes, we do have the color deviation. Inside, I have the deviation tool right here. That's another excellent question. I can say that I want to select a mesh body and a solid body and do a color deviation between the two.
Okay.
And it'll calculate. It'll just take a second on screen. But yes, you can do a 3D deviation between the two and understand maybe where I made a change. As you see on screen here, it may take a second to update. There's a red area where I dragged the pocket. And I can change a lot of the settings here in this dialog. But that just shows you that the tool does exist. There is a deviation tool in there to make sure that you're within a certain tolerance or to make sure that you got everything.
Okay. Once you create a solid model in Spark, can you export it as an STP or an IGES file, or can you use it in other CAD software?
Yes, you can. So if I turn off my mesh on screen and turn my solid on, I can go to the Save As, and I can save as a variety of different interchange formats between parasolids, steps, IGESs. You got a bunch of different options to export. And again, it's going to export as a neutral format. So it'll come in as a neutral format to that CAD package. So depending on the CAD package, you have different tools to be able to then edit and manipulate that geometry after it is imported. But if you needed to manipulate the geometry, you could always do it in here before you send it over as well. So you have a lot of different options there.
Okay, and this one might be for both of you. What level of dimensional accuracy do you get with the scan?
From the scanning perspective, it's the combined accuracy of the arm and the laser line probe, and typically you're looking at about plus or minus sort of 3 thou.
Okay.
And then on the software side, when you're remodeling over top of the mesh, it's really dependent on the engineer himself. So you can follow the mesh as close or as loosely as you would like. So you could model as much detail as possible and follow the mesh close, or you can re-engineer the part and type in the nominal values as you go So that's a little bit of an open-ended question on the software side.
Okay, and this is sort of a follow-up with that in a different sense, but when you're using this tool for reverse engineering, what is the best precision that the combination of tools can provide? And what is the tolerance of the tool for different features? For example, with the guitar body, with a profile tolerance applied to the outside contour, how much uncertainty is put into the model by the scanning and modeling process?
That is a difficult answer to totally analyze, because it could be part dependent. But in general, you have the ability to get within the tolerance of the device you're scanning the object with. And again, it really depends on how close you want to follow the mesh, because what I would say is a manufactured part is actually an imperfect part, and when you reverse engineer, you're trying to create a perfect part from that imperfect part. So there are many times where I deviate from what the actual scan is, because I'm inferring what my design intent is to the object. And of course, you have the ability to do that within the tolerance of the device that you collected it with. So that's probably how I would best answer the question. I don't know if Les has any input on his end.
We have ability to capture different features and different types of geometries in different ways. So where you've got true geometric shapes, then those can be captured with the hard probe at a much higher accuracy than the more freeform surfaces that are best captured with the laser line probe. So you can apply the right horse to the right course. And as Greg says, there's a level of interpretation that needs to happen to that data typically anyway to get the part that you wish to create. The accuracy of the data, of the point cloud data, comes in the number of points that you capture. You could capture with a hard probe points that are within plus or minus 1,000, but if you've only got 3 points defining a surface, it's very difficult to know what that surface is doing between those points. So the laser line probe very, very faithfully represents exactly the exact shape of that surface, if you like, based on the density of the points that you have. I hope that goes some way to answering the question.
Okay. Are there any constraints for rubber molded parts or other flexible parts that can have variation in the scanning process?
The scan system does have the ability to change its exposures and the intensity of the laser line to provide suitable scanning conditions over a wide variety of surfaces. But sometimes when you have challenging surfaces that may have some translucence to them, as the questioner points out, it can introduce some variability, but if possible, you can use various coatings to help overcome that, and use of consistent scanning techniques rather than coming at the part from all sorts of different angles, which give us lots of challenges in managing the physics of the light. Consistency of approach can really help.
Okay. How does Spark deal with missing scan data? This webinar person said that many times they are unable to fully capture the entire part from scanning.
This scan actually that I do have on screen was only scanned from the top, so I do have missing scan data on the bottom. We didn't scan the bottom of the part, but that is what's nice about modeling over top of a mesh workflow is I don't have to have all that information. I can infer the rest of it based on the design and the designer's ability to redesign the part. So it is very easy to scan the necessary areas that maybe you're unsure of the dimensions, align the part to a world coordinate system, model those areas, and then create from scratch the rest of the geometry that is known to you. So that is actually one of the biggest benefits of being able to use Spark alongside scan data.
Okay. If there are other questions from members of our audience, please feel free to go ahead and submit them in. In some cases, some of these questions I think are going to be addressed on a more one-on-one basis, some of them that have come in. So, but feel free to submit the questions and we will continue asking them. One question that just came in is, how much time would it take to recreate this guitar model using this process?
Les, the scanning portion of it, how long did that take you?
That took probably 20 minutes from setup to scan completion.
And then on my side, I know I've reverse engineered this part a few times just because it's a good demonstration piece. But I can do that same demonstration, but dimensioning everything as I go in probably about a half an hour to 45 minutes and have a manufacturable part from there. So it is very, very quick for a simple part like this. And again, this is a simple part, but it's also a part that shows some organic shape to it that would be very difficult to measure otherwise. So it proves very beneficial for showing a scanning system.
Okay, and let's go back over scanning from different directions again a little bit. One of the questions that has come in is how would you combine scans from different directions? But Les, I believe I heard you say that that's something that you might not want to do?
No, that's I probably wasn't clear with what I was describing there. With the FARO scanner, every scan that you take from a different direction it automatically knows where it is in space, so the data automatically is overlaid, unlike other types of scanning solutions where the individual scans have to be pieced together and separately. So as you're scanning a 3D model into Geomagic, or a 3D point cloud into Geomagic Spark. So there's no additional work required unless you need to move the part so that you can scan the underneath or that you can capture some hidden features. In that case, that can be handled very, very easily within the Spark plugin. So it's just a case of defining your first position, scanning from your first position, defining your second position with common areas or common points, and the software will stitch those two data sets together.
Okay.
The point that may have caused the misunderstanding was that when we were talking about the rubber parts earlier, and the questioner was referring to challenging surfaces. If you scan that kind of object from a lot of different directions, the laser line can penetrate the surface to different degrees, causing noise in the data. Typically that noise can be overcome to a large extent by some of the tools within Spark and the Geomagic suite of products. But the better the scan you can produce, the better the end result is going to be.
Okay. And how far should the laser be from a part to acquire proper data or the best data?
The beauty of the laser line probe is that we have a rangefinder built into it, and that also pops up into the software. So as long as the laser scanner is within about 50 to 150 millimeters of the surface, you're going to acquire good data through that whole depth of field.
Okay. So that looks like that's about all the questions that have come in so far. If our webinar team can put up the last slide that shows everybody's email address. If you have a specific question that you would like addressed further, please feel free to contact Les Baker at les.baker@faro.com or Gregory George at ggeorge@geomagic.com. I'm sure both gentlemen would be happy to help you out in any way they can. And in the meantime, we would like to thank everyone for attending this fascinating seminar on how to work with scanners and with the new Geomagic Spark software. Just a reminder, this webinar will be available in a little while on our designworldonline.com website, and those who registered will have it emailed to them. And if you would like to connect with Design World, you can connect with us via Twitter at Design World, with Facebook.com at Engineering Exchange, at LinkedIn at the Design World Group, and on YouTube at youtube.com Design World Video. If you want to have one-on-one discussions on this, feel free to go to engineeringexchange.com and share some of your questions and answers and experience with each other. So I'd like to thank everybody for attending, and thank you very much, Les and Greg, for a very good webinar.